Hello everyone, welcome to today's lecture on Introduction to Machine Learning. So before going with the lecture, let me introduce myself. I hold expertise in reinforcement learning. If you want to access my work profile, you can go to this link. I have several publications in top tier conferences and journals. You can access those from my webpage. I'm currently AI scientist and manager at EY India, where I primarily work on optimal hedging using reinforcement learning and also market surveillance using generative AI. I've received several awards regarding my research, including from organizations like Microsoft and Google and other prestigious organizations. I've also worked on industrial robots at Sony AI Lab, and there are several other awards in my portfolio. And we also have a large AI community named Think AI, where students from all over India are sharing their knowledge about AI. They are learning about AI and all those things. If you are interested in joining that community, you can go to this link and join us on the social media of your choice. Okay, so alternatively, you can join our WhatsApp channel, which is highly super active, and also the YouTube channel. So using this QR code, you can join our WhatsApp channel link, and this is the QR code for our YouTube channel. Okay, so this community or the AI club is totally free, and students are participating in it heavily. And they are doing very good as well. For example, Saksham from MSIT Delhi has secured All India rank of 11 in GATE 2024. Amulya from MIT Manipal secured a research associate position at IIT Delhi. Similarly, other students published papers. So they gave excellent demos, got admission in the higher universities and so on. So there are so many things that the students have actually achieved. And if you want to be part of this club or the community, please join the community. So we have several mentors, and you will be working under the guidance of these mentors. So they are the experts in their community and are working at companies or universities of high repute. Okay, so in today's talk, we will be talking about primarily we'll start with the machine learning applications, and then we'll talk about what is machine learning. And we'll also discuss what are the types of learning in ML and how to set up a data set for ML algorithms. Okay, so what is it that we can do with AI? In ML and AI, we can do many things. For example, we can do advanced analytics where there is a data and we can get advanced business analytics and all those things. In NLP, we can understand the text and then we can understand the speech, and we can actually create realistic conversations. For example, you must be seeing this chat GPT where we can create excellent chatbots, and now the field of customer experience is actually revolutionized by the use of AI and ML. Okay, so another example, if I would like to say, so for example, let's say there is an image and the law enforcement actually wants to understand what these guys are doing. Okay, so let's say, can we create a system which automatically says that, okay, there is something anomalous happening in the public space. Okay, if we can detect it automatically, and then the law enforcement can check it. Okay, another example is in the biomedical image analysis, where identification of the tumors or the cell infections can be automated using machine learning. So for example, both of these are using image segmentation approach to identifying tumors and the abnormal cell structures. Another application is the blind assistance, where either we can create a tool for the education of the blind people. So for example, maybe something which is in the text can be read out, and the blind person can interact with the computer to understand the concepts. Another is for the blind person's navigation. So instead of taking help from the another person, there could be a Google Glass kind of setup where the blind person can actually navigate and will see where he is moving. So what kind of problems you usually show using machine learning? So for example, let's say if our ask is uh, to say whether the image given to the ML system is of a cat or a dog, right? If we are actually asking about this particular question, so that means we want to identify something from the known categories. So for example, like we already know, okay, there are two categories, cat or dog, and we have to answer the question from that. Okay, so then it is called as a classification kind of algorithm. And how much or what value, let's say if we are asking that, so for example, how much it will rain tomorrow, then we are using regression algorithms. If we say that like from the given data, is it weird, right? So that means let's say we are given a rack of potatoes, and we actually identified if there is something which is not following the norm, right? If there are rotten potatoes, right? So just to identify the weird maybe appearances, weird features, or weird like behavior uh, of something of maybe some entity in the data which is not as per the law. Okay, so that is like there we use anomaly detection algorithms. Can we group, right? We don't know the categories. For example, here we knew the categories cat or dog and all those things. Here we don't know, but can we group? So for example, we have a rack of potatoes and tomatoes mixed, right? Can we segregate both of them based on their appearances? So then this is called a clustering algorithm. So there we are actually not creating the groups, but we can say this like we are creating groups based on the appearances, and these groups are also known as clusters. Another like form of learning we are doing in ML is decision making when there is no data available. I think nowadays you must be seeing the robots are coming and all those things, right? So then this is actually done in the reinforcement. Okay, so all of them can be supervised and unsupervised. So for example, classification is a supervised learning algorithm, regression is supervised learning, clustering is unsupervised learning, and reinforcement learning could be both supervised and unsupervised. Okay, and so now let's just see what is machine learning. So machine learning actually has a collection of methods or algorithms which are used to make computers understand patterns in the data without explicit programming. Okay, so these methods enable machines to improve with experience. So for example, let's say we have the data, and let's say there is a machine learning algorithm. We don't know what algorithm is it. Let's say this is a black box. If we are giving the data to this, and then what is the output? The output will be some understanding of the data, whether it is the classification or the groups, clusters, decision making, something, right? Some kind of understanding it is giving of the data, and then we are using this understanding to be used for our purpose, right? So if I say in layman terms, that means we are saying that we are teaching computers to understand the data. So if we are giving images and videos as the input data, then we are solving the computer vision task. We say that we are solving the perception task or the computer vision task. Text and speech data, if it is given, then it is in the NLP, natural language processing task. Okay, now we are seeing old terminologies like AI is there, artificial intelligence, ML, machine learning, and deep learning, right? What is the difference between this? So artificial intelligence contains all the methods that enable machines mimic human intelligence. So whatever umbrella we have, right, that falls into artificial intelligence. So for example, let's say if we are making an algorithm for navigation, right, which is mimicking human intelligence. So that is a artificial intelligence algorithm, AI algorithm, right? Perception, like understanding images, understanding text, speech, whatever, right? It could be AI based algorithm, right? But machine learning contains only those methods that help the computers understand the data. So basically, if the learning is coming from the data, then it is called as ML based algorithm. Other kind of algorithms apart from ML in AI could be logic based programming. So for example, if this that if like so that kind of logic we can embed, and that is also called as AI based algorithm, but that is not ML based algorithm. Example: understanding the medical history of a patient to predict occurrence of cancer. And then there comes deep learning, which is subfield of machine learning. So here, the branch of ML which uses neural networks to understand the data. So the underlying algorithm is based on the neural network, then this is deep learning based algorithm. Okay. Okay, so for example, we look at the MRI scans to answer the patient has a cancer or not. And then there is something called a Gen AI as well, which is a part of deep learning. We will cover it sometime later. Okay, so there are three kinds of learning in ML: supervised learning and unsupervised learning. And there is reinforcement learning as well. So let's say what is supervised learning. So let's say this is our ML model. We have the input data, and with this input data, we also have some other information. So for example, what this data is, which is called as labels, annotations, ground truth, right? You can have different names for this. We give it to the ML model, and it develops some understanding, right? So for example, let's say, okay, so this is an input data, and it says that these are apples. Okay, it will say, okay, these are apples. Okay, and then once the learning is developed, something similar is coming up, and then it will say, okay, my learning is, okay, I learned that this is apple, so it will say that it's an apple. Okay, so that means supervised learning here. The learning is happening when the data is given along with the labels or the ground truth information. Okay, and it is developing some learning, and whenever the new instances are coming, the model is leveraging its learned information, and then it is doing the prediction. Another is called as unsupervised learning, where we have only the input data. We don't have any annotations, right? So the algorithms in the ML in unsupervised learning will actually try to make some understanding based on the appearances. So for example, okay, red circular ones are actually of one kind. Another is like, so maybe something light red or little yellowish and round in the shape, peach. Okay, no, not the peach, but like, let's say the second appearances. Okay, third is like, so something like of the not the round shape but yellow in color is of the third category. So it has actually segregated into different categories based on the appearances, and then we can say, okay, yeah, so whatever name we want to give it, apple, peach, or banana, whatever. But the ML algorithm only understands the color of the appearance. Another type of algorithm is the reinforcement learning, where we have the environment, and let's say we have a robot. Okay, a robot could be there, or something else could be there. So for example, your software could also be there, right? So there could be so many things. So for example, games, right? Okay, now we want to make it understand like what to do, right? So first it will do the observation, and then it select the action using the policy it has, right? And then I don't know what to do. Then it will take the action. Okay, it took the action, and then it gets the reward. Okay, it gets the reward that, okay, a hit sensation is given, -50 reward is given. Okay, get a reward or the penalty, and that it understands that, okay, so this is the bad action. I should avoid this action next time. So it will update its policy. It will learn it. Okay, so this was bad. I should avoid this next time. Okay, it will iterate this process until the optimal policy is learned. So that means the right behavior is learned. So for example, it will first go to the tap, it will open it will fill the bucket, and then it will throw the water on the fire. Okay, so this is the right step of action. So it will keep on repeating all the steps until something is learned. Okay, so this is what reinforcement learning is. And I just see something else as well. So in supervised learning, what we saw, we have the data. The learning is coming from the data with labels. So for example, we have xi. Xi are our data, and yi is the label, associated label. In the unsupervised learning, we are learning from the data without any label. So that means we have only the xi. Okay, in reinforcement learning, we are learning from the interaction with the environment. That means we may have xi, we may not have xi. Okay, so the learning from the data, so the experience is called as the current state of the actor, or maybe the robot, and the action it has taken, the reward it has received, and the next state it ended in. Okay, so this is called as experience. Okay, so there are two types of problems coming in reinforcement, and one is the prediction. So for example, from the current state of the action taken, what will be the next state, and the behavior could be, okay, from the current state, okay, what action should I take? Okay, so I will be talking about these individually in different lectures, but this is what like the different types of learning are there in the machine learning. Okay, a few ML methods that we should know. Maybe we'll talk about each of them individually in individual lectures. So one is the supervised learning. So there are algorithms are like, for example, classic regression algorithms are there, classification algorithms are there. Here we have linear regression, logistic regression. In classification, we have support vector machines, we have neural networks, we have decision trees, we have whatnot. Okay. And unsupervised learning, we have commonly known algorithm is the clustering, where K means clustering is the dimensionally based methods are there. Okay, there is something called as dimensional reduction. For example, PCA, autoencoder are there where we, without using any labeled data, we are reducing the number of dimensions. Okay, we'll talk about that, what it is. In reinforcement learning, we have DPQ networks, proximal policy optimization, AlphaGo, right? We'll also be talking about this. So there is so many things that we can actually do in the reinforcement. So let's just talk about a small pipeline for classification. So what usually happens is, in the older days, what we used to do is, let's say we have some input, right? So the image of a car, and then we first do the feature extraction. So for example, like we'll say, okay, what are the features available? Okay, so there are at the lower part of the image, there are two round shaped objects, and then there are like maybe we will say something uh, some structure is there which has actually like glass appearance. Some structure is there which has metal appearances, and the front bonnet is actually around like has some circular shape. Like top one is more almost flat, back one is almost flat, and all those things, right? So we try to identify all the features that they are there, and then we have a learning algorithm, for example, support vector machine or ADA boost we can use, and then this algorithm learns from these features which category this belongs to, whether it is a car or not a car. Okay, so that means we are doing image classification. The image is of a car or not of a car. Okay, that is what we do. Nowadays we use deep learning, where we directly give the input and it will do the both the things, feature extraction and the classification. We are not actually doing manual feature extraction. It will learn the features as well, and then it will say whether it is a car or not. Okay. Okay. Another like, let's say if I give you a like separate example, let's say we are doing two steps for the classification. One is the feature extraction, second is the classification. The feature is an individual measurable property or characteristics of the input data. So for example, let's say if we give bike as the input, so all the different features we can have like will extract. For example, wheels are there, some like some structure in the wheels is there, the backside, okay, there is a head of the bike and all those things, right? BIM, all these different like parts of the bike which actually makes it a bike, right? So that is what feature is. Another is the classification, which is a process of categorization a given input data into classes or categories. So here, for example, these features, we are doing a learning algorithm. We will say whether it's a bike or not a bike. Okay. So from the non-categories, we know we want only two classes, bike or not a bike. Okay, if we want to do three classes, we'll do three. If we want to do 10 classes, we'll do 10. Okay, we'll talk about like how to do multi-class classification, right? For example, like we will have something in the future lectures, but here we have only the binary classification. Okay, now let me leave you with the like how to actually organize a data set for machine learning, and in the next lecture we will say about supervised learning. Okay, so if we say about UCI machine learning repository, this repository can be accessed on this particular link. When I was a bachelor's or master's student, I used to do all the courses using this machine learning repository, but nowadays we have a very large corpus of data set, right? So this is a very small or simple kind of data sets we have. These are the commonly used for testing ML algorithms. So for example, so we have a heart disease data set, wine quality data set, bank marketing data set, and all those things, right? So all those data sets are there. So let's just see like what a data set actually looks like. So for example, let's say if we see heart disease data set, so it has actually so many information. So for example, what is the characteristic of the data set? It says that it is a multivariate data set. Okay, so that means there are multiple variables we have here. So the attributes that we have here are categorical, are there, integer values are also there, real values are there. So that it is used for classification. The number of instances we have 303. And number of attributes. So for example, so there are 75 variables or the columns we have in this data set. So these are also called as features. Okay, so that means this this, like we can say there are 303 patients and there are 75 features per patient are there. Okay, there are missing values and so on. So these are the things that we have about this data set. Okay, so let's say if we see about the features and labels. So there are the attribute IDs. There, let's say these are the 14 attributes. The attributes are age, sex, CP, blood pressure, cholesterol, and so on. And the description, like, so it describes the age in years. It is the sex is a binary feature, which where one value says it is male, female is 0, and the CP, right, whether chest pain type, what is the chest pain type, and so on, right. So this is what like the data set actually contains, and so this is about the like how the data set is actually organized. Now let's just see how we use this for the machine learning algorithms. We actually create the split of this data set. We usually create 3 splits. So one is a training set, another is a validation set, and third is a testing set. So this is the original data. We create a training set and then the testing set. And then in the training set, we actually divide it into 2 parts, training set and the validation set. In the training data set, we train the machine learning algorithm, and in the validation set, we see how much it is performing so that we can tune or fine tune its parameters and evaluate whether the ML algorithm is performing well or not. Once the validation performance is actually coming out good, we will give this model to the final testing, and the final test data set is actually says that okay, what is the actual performance of the data set. We don't do any fine tuning of the ML model on the testing set. Okay. So now something is so that was a simple visual representation. Now let's just see about some data set. So there are 10 categories. Airplane is there, automobile is there, bird is there, and there are images associated with each of the data set. Okay, so now this is a real data set. Now how to create a training set and the testing set of this? So what we will do is, for each of the category, we will, let's say these are the all images per category. So what we will do is we will create half in the training set and half in the testing set. Okay, we don't do the overlap, because testing set, if there is an overlap between training and testing set, then the accuracy that you will get from the ML model is highly biased, because you have already like trained the model in the testing set. Then it doesn't make any sense to report the numbers on the testing set. Okay, so these are called as labels and ground truth, and then both of the training set and the testing set should contain all the labels. Okay, it depends on the some of the cases where there could be a few categories where we may not have the training or testing set, but that is a different case. But in general, we should try to create this setup, and we should have the split we should have some randomness in the split, so that we are not creating only the first 50% of the data in the training set, which are very simple. So if these are simple, then this will show poor performance. If these are very hard, this is very simple, this will show anyway show very good performance, right? So that's why a mix randomness shuffling is actually important. Okay, I will tell you how to create it maybe in the next class. So, and the training set will have 2 things, X train and the Y train. That is, the X is the data, Y is the labels, and testing set has the 2 things, X test and Y test. And this is the data set and this is the label. Okay, so in the next lecture, we'll be talking about supervised learning, and then the unsupervised learning, when there are so many things will be coming. Okay, so we'll complete the whole ML series, we'll complete the whole AI series, and so on. Okay, so I think we are done. So there is one more thing, like we should ask the right question. So for example, let's say this is the image, right? Let's say if we want to do face recognition. Okay, so this is a synthetic image. The real camera image is not equivalent to the synthetic image, is not equivalent to the real images with some other environmental condition. For example, there is a lot of sun exposure here. There is too much brightness. We are not able to see the half of the image. Okay, so we should ask the right question based on the data. We'll also be seeing like how is it that we can improve the data set and all those things in some of the upcoming classes. Okay, so we are actually preparing an interview preparation lecture series. There will be 3 parts here, where first we will actually cover about all the introduction about programming, ML, AI, and all the advanced algorithms, and then we'll help you with the resume, portfolio building, behavioral interviews, and technical interviews, and then there will be mock interviews, advanced topics, and all those things, right? So these things we will be having. Timeline we will soon post on our WhatsApp channel. So please join those WhatsApp channels. Okay, after the lecture series, you will get mentorship to build your own profile, to build your own projects, and you may also get some internship opportunity if your performance is found to be very good. Okay, so these are our mentors. You can check it, like check their profile online. Okay, so you can join our WhatsApp channel link using this QR code, and subscribe our YouTube channel using this QR code. Okay, so if you have any queries, you can connect with me. So we are done with the lecture. So please join our WhatsApp community and the YouTube channel for the further lectures. Okay, thank you.